So far we have defined the S of 0, which is the initial investment in the stock. So investment in stock, let's say at time t equal to 0, right? And we have also seen that S of 1 is the random value or the random variable that tells us the price of a stock or the share price of a stock. When I say stock, I mean the price of share at time t equal to 1, right? At this instant, and this is random variable. And then we also defined omega. This was the sample space, was the probability space, right? So it contains scenarios like W1, W2, and so on, WN, right? So it could be any scenario. Like if I'm investing, let's say $100, so one scenario could be that this price will be $80, so it could be this scenario, or it could be $90 this scenario. So like these are scenarios or the states that can that can be achieved by an underlying stock, right? And so we also defined sigma field, which was 2 to the omega. So it contains the subsets of omega, right? And then we defined the probability measure. So probability measure was doing what? Probability was giving us the probability of stock being in a particular scenario. So PIs were the probabilities of these sets. So probabilities of stocks being in these scenarios, right? So the probability of the stock to be in a particular situation, or the probability that this scenario will be achieved, right? So these are some of the things which we achieved. So now what we can do is we can define what is going to be the expected values of my stock at time 1. So far we have seen that at time t equals 0, my stock has worth S of 0. At t is equal to 1, it's a random variable S of 1. So S of 1 is, S is a variable which is depending on time t is equal to 1, and it is also depending on the scenario. So in every scenario it has got different value, right? So one can define this as we can also define this as S of 1 comma omega I, which can be written as S of 1 being operated onto omega I, and this can be given as, for example, it can take, let's say, value A1 with probability P1, right? So this probability P1 is the probability that the stock will be in the scenario 1, or the scenario 1, the probability of scenario 1 to happen. So A2 with probability P2. So we will achieve this amount if with this probability, right? We will achieve this amount with this probability. So in this way, right? AN, let's say, with this probability P sub n, right? So we are in a good position to define now expected value of, because this is a random variable, so I will talk about its expectation. So let's talk about that. So probability theory can be recalled, and you must know how we define the probability or expectation of a random variable. So in this case, the random variable is my S of 1. So the expectation of S of 1 is going to be equal to summation I equal to 1 to n of S of 1 comma omega I with probability Pi, right? Or one can write it I equal to 1 to n and S of 1 comma 1 operating on Wi, P of Wi, or P sub I, right? So this is going to be the expectation. So once you have found out this expectation, I can call this as mu, right? So now I can talk about what is going to be the variance of this S of 1, or what is going to be the, so this is expected value which I can achieve at the time t equal to 1, right? This is the expected value of my stock, right? So what is going to be the variance of my variable, random variable s of 1. So it is going to be by using formula summation I equal to 1 to n of so random variable s of 1 comma omega I minus mu, all of this is squared times the probability pi, right? And this mu is this, and obviously if you want to find out the standard deviation, this is going to be just the square root of this variance s of 1, right? So that's how you can calculate all of these things. Okay, we will do an example also. Assume you have got an amount of $80. Let's say you are investing this $80 into a stock, and you have been given the information that at time t equal to 1, your price or the share will be having the value $60, but with the probability p1, let's say, to be 1 over 6, and it can take $80 with probability p2 equal to 3 by 6 or 1 over 2, and s of 1 will be 90 with probability p3, which is 2 over 6, right? So I'm interested in finding out what is the expected value of my stock at time t equal to 1. So by using the formula, my stock at expected value of my stock at time t equal to 1 is going to be equal to summation I equal to, so now 1 to n will be basically 1 to 3, because there are three scenarios. Scenario 1 will be achieved with the probability 1 by 6, and scenario 2 can be achieved with the probability 3 by 6, and scenario 3 can be achieved with the probability 2 by 6. So it's going to be 1 to 3, s of 1 with 1 s of 1 comma omega I, then multiplied by p sub I, right? So this is going to be the formula, which can be expanded s of 1 comma omega 1 p1 plus s of 1 comma omega 2 p2, right, with s of 1 comma omega 3 multiplied by probability 3, right? So this can be, so the value of stock at time 1 and scenario 1 is $60, and the probability of happening this is 1 by 6 plus the value of stock can be at time t equal to 1 and scenario 2 to be $80 with probability 3 by 6 plus, so s of 1 comma 3 is going to be this 90 times 2 by 6, right? So this is going to be 10, and this is going to be so what is going to be this? So 3 will divide 6 2 times, and then 2 will divide 40 times, right? And 6 will divide 90 15 times. So if I'm not wrong, or if I haven't made any calculational mistakes, then this answer has to be 80. So basically expected gains or expected value that my stock can take at time 1 is basically the same as the investment. So like there are no any expected returns at this time, right? One can ask what is going to be the variance, so I will record this as mu, which is 80, right? So what is going to be the variance? So now you can just use the formula. So my variance had the formula variance of s of 1, and this was equal to summation 1 to 3 in this scenario. So the value of stock at 1, or the investment at 1, wi minus mu, and square times pi, right? So now you can just substitute values. So the value of s of 1 comma omega 1 was equal to let me see this, so it was equal to 60, right? 60 minus 80 square with probability 1 by 6 plus 80 minus 80 with probability 1 by 2 or 3 by 6 plus it is 90 minus 80, right, squared times probability 2 by 6, right. So this is going to be 20 square, which is 400 divided by 6, and this is 0. And this is going to be plus 10 square, which is 100, right, times 2 divided by 6. So it is 400 over 6 plus 200 over 6. So if I'm not making any mistake, so you need to check these calculations. I can make calculation mistake. So this is going to be 600. So it should be 100, and the standard deviation will be equal to the square root of this 100, which is basically 10. So that's how you can tell about your investment. So you had $80 in your pocket, and you purchased let's say the one share, let's say of and $80, you let's say you have purchased the stocks, and at S1 your payments could take these possible values. So it could take 60 with some probability, it could take 80 with some probability, it could take 90 with some probability. So what you did, basically you calculated the expected value of your investment at time t equal to 1, and it turned out to be 80 cent, and then you calculated its variance, which was 100, and then you calculated its sigma, which was 10. So that's how you can play.